Right. So what are you actually doing when you're doing integration? What you're actually doing when you're doing integration is you are determining the area under a curve. Okay. So here we have A1, here we have A2. So there are two areas under the curves. In order to find the area under the curve, you're going to integrate. Okay. The difference with this question and the other question that we dealt with in the previous video is that here we have a definite integral. That means we're starting somewhere and we're ending somewhere. Remember, you always start by the small one and you end by the bigger one. So, okay, number 7.1, there they just want, or 9.1, 9.2.1 rather, there they just want you to take the integral of this. So let me do it over here, integrate 3 to the power of x. Okay, so again, in the previous video, I discussed the three basic rules. So what do I see? I see that x is my exponent. And if x is my exponent, I know I'm going to write down exactly what I see. So I'm going to say 3 to the power of x. Then I'm going to divide. What am I going to divide with? Ln of my base. In this case, my base is the 3. And my coefficient over here would be the coefficient of x, which is a 1. So I don't really have to write the 1. So that's my answer. Don't forget your plus c. Right, but now the next part of the question over there, we have this A1 and A2, which is your area under the curve, right? So the curve is 3 to the power of x. So this over here is going to be the integral that we're going to use. Great. We just need to know our limits. Let me write this first. So we have an integral, and we are starting somewhere. So we start at the -1, and the starting point goes at the bottom, and we're ending at the 0. The end point goes on top. So starting there, ending there to find this area. Okay, so let's do that quickly. Again, the function is 3 to the power of x and dx to say that we are applying the rule on the x. So we're differentiating with respect to x, or we're integrating with respect to x. Okay, right. So now we're going to drop this symbol because we're going to apply the rule. So what is the rule? I write down exactly what I see. I divide by ln of my base. There is no coefficient on the x. Well, there's a 1 there, so the coefficient in front of the ln would be 1. So that's what I do, right? But I'm not going to put my plus c. The reason that there's no plus c is because this is a definite integral. With the indefinite integral, you put the plus c. But once they give you the upper and the lower limit, once they give you the limits, then you don't put the plus c. What you do is well, let's make this square brackets, and we say the -1 and the 0. Those values need to be substituted into the place of x. So we'll do that in the next part, right? So we'll say that now what am I going to have? I'm going to have 3 to the power of, I'm going to substitute the upper limit first. So 3 to the power of 0 divided by ln of 3. And then I'm going to have a minus. And over here, I'm going to have my second substitution. Okay, so what I'm going to have now, I need that minus there. Now I'm going to have the -1 subbing in x's place. Okay, so now I'm going to say 3 to the power of -1 divided by ln of 3. Right, so I'm going to take a second. I'm going to go put this in my calculator quickly. Right, and my calculator says the answer for this is 0,61. Okay, so I'm rounding off to one decimal place. Calculator says 0, or two decimal places, 0,61. Then they want me to find the area of a 2. So I'm going to do exactly the same thing. Now my limits are 1 and 3. Okay, so again, all of the same stuff. I'm taking the integral. I start at 1, I end at 3. My function goes over here. My function is 3 to the power of x dx. Okay, again, all of the same stuff. So I'm taking the integral now. So I'm going to write exactly what I see, 3 to the power of x. And this is divided by ln of 3, ln of my base. Okay, this is a definite integral, so I know that I have limits. My lower limit is 1, my upper limit is 3. I'm going to plug this 3 in x's place. So I'm going to say 3 to the power of 3 divided by ln 3 minus, I'm going to plug the 1 in x's place. 3 to the power of 1, that 1 can be invisible, divided by ln of 3. Again, let's go put this in the calculator. Right, my calculator says 0. So I just need to double check to make sure that okay, I made a mistake. Let me just change this. That is supposed to be, okay, my answer should be 21,85. Right, okay. So I've got A1, I've got A2, okay? So this is A2. Let's just say this is A2. And this one was A1. All right, so what did they ask us? Let's just go check the question again. Show whether or not the area of A1 is 30 times less than that of the area of A2. Okay, so I'm going to say A2 divided by 30. And let's see what I get. Divide this with 30. And I get 0.73. So is the area of A2 30 times less than the area of A1? Is that the same as area of A1? No, it is not. Alright, so I would make my conclusion that the area of A2 is not 30 times less, right? Unless there's a mistake somewhere that I've made, right? But I think that we are okay. So maybe just a summary. What did we do? The integral, so we made the integral symbol. We have a definite integral, so we have a limit from somewhere to somewhere. So we started by the -1, went up until the 0. The function was 3 to the power of x. I remember to say dx. We applied the rule on that. Then we did the substitution of the upper one minus the substitution of the lower one, and we did the same thing on the other side again. All right, so those are our definite integrals.